My dear students, today I am going to discuss some smart tricks for maths. Actually, these are some ways or methods in order to reduce your calculation work in maths. Okay, then let us start with smart trick number 1. Now this is about finding LCM of some numbers. Now you find LCM by what method? Prime factorization method, short division method. But before using those methods, you can cancel out some numbers. For example, look at this LCM of 2, 6, 8 and 12. Now you see 2 is a factor of 6 or 8 or 12. Therefore, you can remove this 2. 6 is a factor of 12. So you can remove this 6. 8 is not a factor of 12. So these two numbers remain. So finally, it comes down to LCM of 8 and 12. So let me repeat. Suppose you have to find LCM of 2, 6, 8 and 12. So you can remove 2 and 6 because 2 is a factor of 6 or 8 or 12. 6 is a factor of 12 but 8 is not a factor of 12. Therefore 8 and 12 will remain, 2 and 16 are removed. So finally it comes down to LCM of 8 and 12. And you can very well find out LCM of 8 and 12 by prime factorization method or short division method, whichever you like. So LCM is 24. Okay. See the next example. LCM of 3, 5, 10 and 15. Now 3 is a factor of 15. So cancel 3. 5 is a factor of 10 or 15. Cancel 5. Now 10 is not a factor of 15. So 10 remains, 15 remains. Now it comes down to what? LCM of 10 and 15, which you can find out as 30. Alright. Similarly, suppose this LCM of 3, 4, 5, 6, 8 and 10. Now we can remove 3 because it is a factor of 6. We can remove 8 because it is a factor of, we can remove 4 because it is a factor of 8. We can remove 5 because it is a factor of 10. So out of these 6 numbers, 3, 4, 5 are gone. Now 6 is not a factor of 8 or 10. 8 is not a factor of 10. So these 3 numbers remain. So again it becomes what? LCM of 6, 8, 10. And LCM of 6, 8 and 10 you can find out by any method. It will be 120. Alright. Now let us see this last example. LCM of these A, B, C, D, E, F, G. Suppose these are some numbers. Now A is a factor of D. So you can remove A. B is a factor of F. So you can remove B. C is a factor of E. C is a factor of E. So you can remove C. Now E is a factor of Z, so E is a factor of Z, so we can remove E. So A, B, C and E, A, B, C and E are removed. So what remains? Now if D is not a factor of F and Z, D remains. F is not a factor of Z, so F remains. G is not a factor of D or F, so G remains. So these 3 remains. That means D, E, G remain. So finally it comes down to LCM of D, F, G. So this is the trick, you see. So in order to remove some numbers, what you do? You see the factors and then remove those factors. Is it clear? Okay, now let us see smart trick number 2. Now how to simplify equation. Now look at this equation. Twice x plus 4y equal to 10. Now we can reduce these numbers. We can make them smaller, 2, 4 and 6. Now 2, 4 and 6, they have a common factor 2. 2, 4 and 10, sorry, 2, 4 and 10. These 3 numbers have a common factor 2. Therefore, we divide by 2. So 2x divided by 2, 4x divided by 4y divided by 2 and 10 divided by 2. Now 2x divided by 2 will be what? X. 4y divided by 2 will be 2y. That is equal to 5 divided by 2, 10. So you see that equation now becomes a simpler one. X plus 2y plus 5. Originally it was twice x plus 4y plus 10. Now we divided each term by 2. Why 2? Because 2 is a common factor of 2, 4 and 10. And dividing each term by 2, what we got? 2x by 2x, 4y by 2, 2y and 10 by 2, 5. Similarly, look at this equation. 3 into x plus y plus 6 plus 15. Now 3, 6 and 15, they have a common factor 3. So we divide by 3. So 3x plus y divided by 3, 3 cancel, x plus y remains. 6 divided by 3, 2. And 15 into x minus y divided by 3, what you get? 5x minus y. So this whole equation becomes a simpler one, x plus y plus 2 equal to 5 into x minus y. So we have divided each term by 3 because 3 is a common factor of 3, 6 and 15. Similarly here you see ax plus a square y plus a cube xy. Now common factor is a, so we divide by a. So ax by a x plus a square y by a, so ay. Then a cube xy by a square xy. So this equation becomes x plus ay equal to a square xy when we divided each term by a, because a is a common factor of these three terms. So the equation has become quite simple. Now in all these three examples I have shown that we are dividing by common factor. Now in the remaining these two examples you will see now we multiply. Now we multiply to remove fractions. Now you see this equation, x by 4 minus xy by 6 equal to 5y by 12. Now in order to remove the fractions, we multiply each term by LCM of denominators. Now 4, 6 and 12, LCM is 12. Now already I discussed in the first trick, 4, 6 and 12. Why LCM is 12? 4 is a factor of 12, 6 is a factor of 12. So 4 and 16 gone, so 12 remains. So you can find out by any method. So 4, 6 and 12, these are the denominators, and LCM of the denominators is what? 12. So we multiply each term by 12. Now x by 4 into 12. So you see x by 4 into 12. What do you get? 4 and 12 cancel 3. So 3x. So you see 3x. Then 6y, xy by 6 into 12. So 6 and 12 cancel 2. So 2xy. Then 5y by 12 into 12. 12 cancel 5y. So we multiply each term by LCM of denominators. So this into 12 gives 3x, this into 12 gives 2xy, and this term into 12 gives 5y. So you see fractions are gone. Similarly, look at this example. Again there are fractions. X plus y by 2. Half into x plus y means x plus y by 2. 1 by 4 xy means xy by 4. 3 by 8 x minus y, that means 3 into x minus y by 8. Now what are the denominators? 2, 4 and 8. So we find LCM of denominators 2, 4 and 8. Now what is the LCM? 8. So we multiply each term by 8. So when you multiply this term by 8, it becomes 4 into x plus y. When you multiply this term by 8, it becomes 2xy. And when you multiply this term by 8, it will become 3 into x minus y. So you see fractions are removed. So in these two examples, what we did, we removed the fractions by multiplying each term by LCM of denominators. So in these examples, we divided by the common factor, and in these two examples, we multiply by LCM of denominators. So using this smart trick, you can simplify the equation. So that will reduce your workload, and also another important thing, it will save time in exam. Time is very important in exam, isn't it? Okay, now let us see the third smart trick. Now this is to convert, so this, how to convert kilometer per hour to meter per second, or how to convert meter per second to kilometer per hour. Now to convert kilometer per hour to meter per second, this is a multiplying factor, 5 by 18. So you multiply by 5 by 18. For example, 60 kilometer per hour. You want to convert to meter per second. So you multiply 60 by 5 by 18. 60 into 5 by 18. 60 into 5 by 18. So you cancel by 6, 6, 3, 6, 10. So it becomes 50 by 3. 50 by 3 meter per second. Have you followed? So to convert kilometer per hour to meter per second, what you do? You multiply by 5 by 18. That is the multiplying factor. So see another example. Now it is the opposite. Now see in the next example the opposite. Convert meter per second to kilometer per hour. How to convert meter per second to kilometer per hour? Now you multiply by 18 by 5. In this case, you multiply by 5 by 18. Now, in this case, you multiply by 18 by 5. So, to convert kilometer per hour to meter per second, you multiply by 5 by 18. To do the opposite, to convert meter per second to kilometer per hour, you multiply by 18 by 5. For example, this one, 20 meter per second, you want to convert to kilometer per hour. So, multiply by 18 by 5. So, 20 into 18 by 5. So, you get 72 kilometer per hour. So, 5 and this cancel 4 into 18, 72. So, 20 meter per second is what? 72 kilometer per hour. So, see another example, 5 meter per second. So, multiply by 18 by 5. 5 into 18 by 5. So, 5 cancel, 18 kilometer per hour. 18 kilometer per hour. So, using this trick or method, you can convert kilometer per hour directly to meter per second, multiplying by 5 by 8, or you can convert meter per second to kilometer per hour directly by multiplying by what? 18 by 5. Otherwise, you have to do slightly longer way in the normal method. Okay. All right. So this is about that conversion of kilometer per hour to meter per second and all that. Now let us see the next smart trick, number 4. Now this is also conversion. How to convert centimeter to meter, how to convert centimeter square to meter square, how to convert centimeter cube to meter cube. Alright. Now centimeter and meter are units of length, centimeter square and meter square are units of area, and centimeter cube and meter cube are units of what? Volume. Now to convert centimeter to meter, simply divide by 100. Divide by 100, isn't it? So 50 centimeter you want to convert to meter. So 50 divided by 100, divide by 100, because 100 centimeter equal to 1 meter. So 50 by 100 is what? 0.5 meter. So 50 centimeter means what meter? 0.5 meter, dividing by 100. Okay. Now you want to convert centimeter square to meter square. Centimeter square to meter square. How to convert? Divide by 100 square. So centimeter square to meter square. So divide by 100 square. You see, suppose 5000 centimeters square. You want to convert to meter square. So you divide by 100 square. So what do you get? 5000 divided by 100 square. 100 square means 10,000. 100 into 100, isn't it? Now 3 zeros cancel. 3 zeros cancel. What remains? 5 by 10. 5 by 10 is 0.5 meter square. So 5000 centimeter square is equal to what? 0.5 meter square. So how you did? Dividing by 100 square. Okay. Now come to this one. To convert centimeter cube to meter cube. To convert centimeter cube to meter cube, you have to divide by 100 cube. Cube, cube, cube. Alright. Suppose this one. 2 into 10 to the power 7 centimeter cube. 2 into 10 to the power 7 centimeter cube, you want to convert to meter cube. You want to convert to meter cube. So you divide by 100 cube. Divide by 100 cube. So 2 into 10 to the power 7 divided by 100 cube. 100 cube means 100 into 100 into 100. That is, there are 6 zeros. So 1 and 6 zeros. So 10 to the power 6. So 2 into 10 to the power 7 divided by 10 to the power 6. So it becomes 2 into, this is 7 minus 6, 1, 10. The 10 to the power 1 means 10. So 2 into 10, 20 meter cube. Alright, so you see 2 into 10 to the power 7 centimeter cube is equal to 20 meter cube. So you see what to do. To convert centimeter to meter, divide by 100. To convert centimeter square to meter square, divide by 100 square. Square, square, square. To convert centimeter cube to meter cube, divide by 100 cube. Cube, cube, cube. So that is the trick. Okay. Alright. Now let us go to the last one. Smart trick number 5. Now how to remove decimal point. Now in order to remove decimal point from fractions, what you do? You multiply both numerator and denominator by sometimes 10, sometimes 100, sometimes 1000, sometimes 10,000 and all that. Isn't it? Now without doing that kind of multiplication, see how you can do easily. Now consider this one, 3.52 divided by 1.9. Now you want to remove the decimal. So you count after decimal there are 2 digits, 5 and 2. And here after decimal there is only 1 digit, 9. So you put a 0 and make 2 digits. So 1.9 you rewrite as 1.90. Now you see after decimal 2 digit and after decimal 2 digit. So originally after decimal there were 2 digits, but here there was 1 digit. So we made 2 digit by putting a 0. So here now after decimal 2 digit, after decimal 2 digits, same number of digits. Now simply remove the decimal. It becomes 352 and it becomes 190. So the whole thing becomes now 352 by 190. So we have removed the decimal. Now next example you see 0.05 divided by 1.627. Now after decimal 2 digit, after decimal 3 digit, so you make both 3 digit. So put a 0 here. See 0.050 and this one same 1.627. Now after decimal 1, 2, 3 digit and after decimal 1, 2, 3 digit. So same number of digits after decimal. So just remove the decimal. This will become 1627 and this will become 0050. That means just 50. So 50 by 1627. Alright. See this next example. 0.0501 by 1.2. After decimal 4 digits. After decimal only 1 digit. So make 4 digit by putting 30. Now look at here. So after decimal 1, 2, 3, 4 digit. After decimal 1, 2, 3, 4 digits. So 4 digit, same number of digits. So just remove the decimal. This will become 12,000, 12000, and this will become 00501. That means 501. So that is the way. Similarly, 56 by 3.25. Now when you don't see any decimal, it means it is at the end. 56 means 56 point. Similarly, 2 means 2 point, like that. So 56 point. So after decimal 2 digits. So after decimal put 2 zeros so that number of digits becomes same. After decimal 2 digit. After decimal 2 digit. So now remove the decimal. This will become 325. This will become 5600. Okay. Now look at the last one. 2 by 0.005. Now 2 means 2 point. So this after decimal how many digits? 3. So put 3 zeros so that number of digits become equal. So after this decimal 1, 2, 3 digit. After decimal 1, 2, 3 digit. So this becomes 2000. This becomes 0005. That means only 5. So you see, in order to remove decimal, what is the principle? In both numerator and denominator, you make number of digits after decimal same. So after decimal, in numerator, denominator 2 digits. After decimal, 3 digits. After decimal, in the numerator, denominator 4 digits. After decimal, 2 digits. After decimal, in the numerator, denominator 3 digits. After that, simply remove the decimal, rub off the decimal, forget the decimal, and then you get these numbers. So these are a few of the smart tricks which you can use in exam to reduce your calculation work, and more importantly, as I said before, to save time. Okay. So there are some more tricks which I will explain in my video in future. Okay. All right, for today then. Thank you.